We've all been part of that roundtable discussion of backup power solutions, and the two words that are most commonly thrown around are generators and inverters. Be it an inverter backup or a solar setup, those are both coupled to batteries. But I'm going to add a third concept into the mix, an inverter that is powered by an engine, or an inverter generator. But Kevin, what's an inverter generator and how does it differ to a normal or traditional generator? Let's jump straight in and start with a quick science lesson. Today, class, I'm looking specifically at domestic type generators. You know, the 5,000 watt that your friend down the road has? Now, in a conventional non-inverter generator, the engine tries to operate at a constant speed and drives an alternator that produces electricity, which in South Africa is 220 to 240 volts at 50 hertz. So here there is some leeway with the voltage range, but not the frequency. Now, the automatic voltage regulator, or AVR, that is built into the alternator tries to keep the voltage stable under varying load conditions. Coupled to this is frequency, or hertz, which is a measure of electrical cycling, hence the name alternating current. Now, our electricity is set at 50 hertz, not 49, not 51, 50. The governor inside the engine tries to keep the motor speed at a constant RPM under varying loads to produce a set 50 hertz frequency. If the engine speeds up, so does the frequency, and vice versa. And it's the inconsistent frequency that causes damage over time to sensitive electronics. An inverter generator, on the other hand, is completely different. Think of the engine and the alternator as a battery. The alternator produces DC power, DC standing for direct current. Now, direct current power, or DC power, does not have a hertz component. This DC power is then fed into an inverter, and the inverter, through electronics, inverts this DC power to AC power. And because it's an electronic modulation, the power produced is clean power. It's at 50 hertz on the dot. Let me show you what I mean. So here I have a little hertz meter that I borrowed from a friend. This simply plugs in and measures the hertz frequency of the electricity. Remember, we want a stable 50 hertz. I've also got a multimeter that can test a number of things. Today we're testing AC, and we're looking for a voltage between 220 and 240. Let's start with our main utility supply as a reference. Here we can see we have 226 volts and a steady 50 hertz. Perfect. Now, to introduce a load, there it is. I have a power-hungry 2,200 watt angle grinder. We're going to plug this in, and when I squeeze the trigger, let's see what happens on the dials. As expected, no change on the frequency, a slight variation on the voltage, but still well within limits. Now, let's repeat the same exercise with a traditional 5,000 watt non-inverter generator. Exo, when you're ready, can you start the Jenny? Right, let's have a look here. Our incoming voltage, 228, 226, 28, 27. But interestingly, our hertz is sitting at about 51 hertz. It's slightly higher than normal because there's no load. Now, as soon as I start this angle grinder, let's see what happens. So we saw there that the voltage remained between the 220 to 240 range, but the hertz dipped down to about 49 hertz. And what's more, you can see it's hunting and trying to get to the 50 mark. Now, as I turn the angle grinder off, that needle jumps up to about the 51 mark. The governor takes over and it brings down the hertz back towards 50. It's still slightly above our appliance requirement of 50 hertz. Now, this is what we call dirty power. Imagine what those spikes are doing to electronics such as computers, TVs. Even your LED lights and appliances have electronics inside that are slowly getting damaged over time. Exo, can you give me a hand to get this guy outside? Let's plug it in and start it up. I mean, you can hardly hear this running. It really is that quiet. I'm not talking any louder than normal. Let's plug this in and go inside and have a look at those gauges. Our inverter generator is running 235 volts, 234, but have a look at this. That needle is pegged on 50. There's absolutely no movement whatsoever. Now, let's push play with the angle grinder. Watch carefully. Let's see what happens. That needle did not move off 50. Let's see if we can get it to bounce by starting and stopping this quite a bit. That needle hardly moved, 0.1 of a hertz maybe. That, people, is clean electricity, clean power. And it's that clean power that we should be feeding into our homes and offices as soon as there's electronics involved. Power tools don't mind dirty power, so yes, there is still a place for a traditional generator. But as soon as there's electronics involved on the load you wish to power, I would strongly recommend using clean power. Folks, allow me to introduce the Steco 5000 watt dual fuel inverter generator. The inverter generator I used for the bench tests, man, am I impressed. The 5000 watt generator is housed within a closed frame unit and is powered by a 4-stroke engine with a peak capability of 5,500 watts. The closed design significantly reduces noise compared to open frame models. Although small by design, it does still weigh 40 kilos, but that's about half the weight of a comparative 5,000 watt traditional generator. The fold-up handle and the rear wheels make it easy to move around when it's on a flat surface. Now let's address the intriguing feature, dual fuel. This motor runs on standard unleaded petrol as well as liquefied petroleum gas, LPG. It's the same gas that you use for your gas fry and perhaps even in your kitchen. Talk about flexibility. So how do we set this up and run this on the two different fuels? It's not that difficult. Now your new generator needs to be filled with 700 mils of 4-stroke engine oil, the same as you use in your car. This has already been done for me before the unit arrived at the studio, so let's move along. Petrol is added through the filler cap and has a capacity of 11 liters, which will give you a claimed runtime of 5 hours. That's 2.2 liters of petrol per hour, or approximately 1.5 kilos of LPG per hour, with no load. Now, if you're running a big load, expect those run times to drop slightly. LPG gas is connected via the supplied gas hose, which screws in on the LPG inlet port and then screws onto your cylinder. Just take note that this is the larger of the two thread sizes we get in South Africa. It's a 5/8 inch BSP, commonly known as a bullnose adapter. Screw the regulator on and open the valve. Now the option of being able to run on gas means I don't have to carry petrol jerry cans that are notorious for spilling in the boot of the car, and having those fumes on a long trip, not lekker. This engine control dial has 4 settings, namely off, run, LPG and petrol. The generator will default to gas as its primary fuel source. So if you're wanting to run on petrol, make sure that the gas line is disconnected or that the gas bottle has been turned off. If you're starting the engine from cold, set the dial to your preferred fuel source and press the red start button. As soon as it starts, turn the dial back to run, where you'd leave it there until you're ready to turn the unit off. If the engine is warm, it may not start immediately, in which case, simply set it to run and press the starter. These other 2 settings basically activate the choke for cold starts. Now when running on petrol, ensure that the breather cap is set to the open or on position to prevent an airlock in the tank. The generator does also have a recoil pull start should the onboard battery be flat. Okay, so she's running. But you can't hear me with that going. Now we can hear that it's much quieter than a traditional generator. We can also hear that it's not running at full RPM. On the front panel, we have a basic LED display that gives us information such as volts, frequency, and amp draw. There is also an eco switch, which slows the engine down when under low load. And as we increase the load, so the engine speeds up to generate more power to supply the load, and thereby saves fuel under low load conditions. The same in reverse. As the loads are removed, the engine will slow down again. Turning the eco mode switch off will have the motor running at full RPM, and this you would generally only use if you've got a few people using power tools all at the same time and you want maximum power. 2 standard plug points are fitted, as well as a dedicated 12 volt 8.3 amp output. This can be used to power any 12 volt items. You can even charge a battery on the go. There's also 2 USB charging points, handy for charging a cell phone, and the parallel operation port allows you to connect 2 Steco inverter generators together, effectively doubling your usable wattage. This generator has seamless switching between gas and petrol. Here I am running on petrol. My cylinder is closed. As I open the gas supply, the generator coughs slightly and then runs on gas. When I close the gas, she coughs again and switches to petrol. Now you'll see on the multimeter and Hertz meter that there's no break in electrical supply during switching. The gas fuel option does reduce the maximum power output to 4,500 watts with an additional 500, giving us 5,000 watts for peak. compared to 5,000 continuous on petrol with a peak of 5,500. Folks, I'm seriously impressed with this inverter generator. It's neatly packaged and it can run on the more pocket-friendly fuel option, which is LPG. Now, if you're looking for a new generator, I urge you to give this considerable thought. And as much as it may cost a bit more to purchase, you'll find that in the long run, you're going to be preserving your electronic items. It just makes sense all around. This Steco and other Steco, as well as Ryobi products, are available at builders, either in-store or online at builders.co.za. It's due day for clean, portable power. Get to Builders, get it done.